Experiment where you are trying to find out the heat transfer coefficient under natural convection of a vertical cylinder, right? So you know what is the convection. So convection heat transfer is the heat transfer between a solid surface and a surrounding fluid, right? So if the solid surface is at a higher temperature, then the heat transfer would occur from the solid surface to the surrounding fluid, right? Or if the surrounding fluid is at a higher temperature, then the heat transfer would occur from the surrounding fluid to the solid, right? So here there is a heater inside a vertical cylinder. That means the cylinder is getting heated up, right? So I need to find out what is the heat transfer coefficient of this heated vertical cylinder under natural convection. So the convection is of two types. So one is the forced convection, another is a natural convection, right? Suppose if I am creating a fluid motion by some external power, then it becomes a forced convection, right? So I can cool a hot plate in the open air, right? So then that is the natural convection. Suppose if I am putting a fan or a blower on the top of that and I am trying to cool that hot plate, then it becomes forced convection. So here what I am doing is I am conducting the experiment on natural convection. I am trying to find out what is the heat transfer coefficient, right? So for heating the vertical cylinder, we need to give the input to the heater, right? So you will be in the question paper it will be mentioned what voltage you need to keep for the heater, right? Suppose you are asked to take, let us say, readings for 60 voltages and 70 voltages and 80 voltages. So initially you keep the voltage reading as 60. So there is a variable rheostat which is there. By operating the rheostat, the voltmeter reading can be set up, right? So just by rotating this clockwise, the voltage is increased, right? Once it reaches close to 60, you fine tune it so that this voltage is maintained, right? So again it is slightly adjusted and now the voltage is set, and this gives you the corresponding the current that is flowing through the heater. So the total heat input is obtained by multiplying the voltmeter reading and the ammeter reading. So that gives you what is the wattage that is given to the heater, right? Once this is done, now I need to find out the surface temperature of the cylinder. So basically the relation that is used to calculate the heat transfer is, that is Q is equal to AH into the surface temperature minus the ambient temperature, where H is the heat transfer coefficient, right? So here the total heat transferred is whatever the amount of heat which is given to the heater would be finally convected. So the heat transfer is Q, that is found out with the help of the multiplication of voltage and the current. So Q you are finding, right? So then you can find out the heat transfer coefficient H as Q by A into Ts minus Ta, right? So Q is the total heat transfer, so that is the total power input to the heater, so that is found out, and A is the surface area of the cylinder. So the outer surface area of the cylinder, you know the diameter and the length of the cylinder, so you can find out what is the area, then Ts minus Ta. So I need to find out the surface temperature of the cylinder. So for finding the surface temperature of the cylinder, so there are thermocouples, the temperature sensors which are placed at the outer periphery at different locations. So basically I have some 7 thermocouples are placed from the bottom to the top, and the temperature at each and every location can be found out with the help of a temperature indicator, right? So there are some buttons which are the push buttons are there both at the bottom side and the top side. Just by pressing these buttons I can see the various temperature. Now I just kept it 1, that means it gives me the temperature T1. So like that I am just pushing up and down. I can read the various temperatures T2, T3, T4, T5 like that, right? So what I do is, now the voltage is set, I just keep the temperature sensor at T1 and I am just observing the temperature and I am just waiting this temperature to become steady. So once this T1 becomes steady, I assume that all the other temperatures also become steady, and immediately I am just noting down all the other temperatures, T1, T2, T3 up to the T8, and T9 would give me the ambient temperature, right? So
T9 is the ambient.
T9 is the ambient. T1 to T8 at the different.
T8 is ambient here.
T8. Okay. So that means
T8 is
ambient. T1, T2, T3, T4, T5. Yeah. Till T7. Till T7, that gives me the surface temperature, and T8 is the ambient temperature, right? So the TS is calculated by finding the average of T1 to T7. T1, T2, T3, T4, T5, T6, T7 divided by 7. That gives you the average surface temperature of the cylinder. So I can find the heat transfer coefficient H at the given voltage, right? So now the set of readings for 60 is done. Now we will go for, suppose we are asked to find out 70 voltage. Then vary the rheostat, set the voltage 70 and repeat the procedure.